Hi everyone, welcome to my talk on group belief revision and scientific change. First, I want to note that this presentation will deviate slightly from the abstract. My positive views have changed in the last few months, so I'll now be presenting the most up-to-date version. Let's start with some motivating examples. Group beliefs are not static. For example, cosmologists now believe most of the universe's mass is made up of dark matter. In the early 20th century, the physics community rejected ether theories. Particle physicists revised their model in order to resolve the solar neutrino paradox or problem. These are all examples of how science have changed over time. The scientific community and scientific groups that are researchers who are working on these problems have changed their views over time. How do we capture these types of changes? Well, there has been many different proposals about what group beliefs are or are not, and how they are formed. Group belief revision has surprisingly received a little philosophical attention. For my purposes, I will presume that groups can have beliefs, or at least weaker cognitive attitudes like acceptance. We can also make use of things like group views if one is particularly adverse to theorizing about group beliefs. So group revision, belief revision are changes in views. For epistemic groups, the problem of group belief revision is particularly pressing because it is directly related to group rationality. If we're to responsibly uptake the testimony from epistemic groups, we should evaluate whether the epistemic group is behaving rationally, being reason responsive, and revising its beliefs when confronted with countervailing evidence. My primary targets in this talk are epistemic groups, which are groups that are formed in pursuit of epistemic goals. Scientific communities and research teams in particular are paradigmatic epistemic groups. And if you recall those examples I just gave, I try to capture sort of like the paradigmatic types of epistemic groups that I think a theory of group belief revision should capture. So the question I want to answer is, how do groups update their beliefs? How do the group and its members evaluate new evidence? How do the group and its members decide how to respond to evidence? And how are groups constrained by their previous views? I want to note that I am more interested in group dynamics rather than the update rules themselves. I'm not interested in proposing new update rules or a logic for belief revision. Of course, much work has been done on these topics from the perspective of individual epistemology. Rather, my focus here is to explore how belief revision happens in groups. And to preview the rest of this talk, I will be arguing against a prevailing view in the literature, one that has been defended by Margaret Gilbert, that what constrains group belief revision is joint commitment, a sense of obligation to other members of the group to uphold the status quo. This analysis renders group belief change to be an irrational process, not answerable to epistemic norms. I argue instead that the normative constraints on group belief revision is the weight of the evidence being considered by the group, and to understand group belief change, we need a better theory of how epistemic groups respond to evidence. Given the time restraints in this talk, I will not be able to kind of fully flesh out my positive view. So I'll endeavor to set up the problem clearly and to kind of give a sketch of what I think of an alternative view to Margaret Gilbert would look like, and also give a very quick case study to capture sort of what needs to be addressed in thinking about scientific change. Okay, so first let's talk about Gilbert on belief change. So in a paper in an essay in 2000, Margaret Gilbert asks a very interesting question. She asks, is scientific change a matter of individual scientists changing their minds, or is it a matter of scientific communities changing their minds? She argues She, of course, defends one of the classic inflationary accounts of group belief. A classic deflationary account, in contrast, is summativism, where a group believes that P when some or all of its members believe that P. Margaret Gilbert argues instead that there is an important sense in which groups have beliefs over and above its members through a joint commitment. There is a collective belief that P if some persons are jointly committed to believe as a body that P. Joint commitment is a technical term. Gilbert has argued that it is at the very heart and foundation of social interactions. A joint commitment is created when each of the parties has expressed his or her personal willingness to be party to it under conditions of common knowledge. And given a joint commitment, the parties to it are bound together and are subject to it all until all parties concur to rescind it. Furthermore, while the parties are subject to a joint commitment, they have obligations and rights in relation to one another. Here's a quote from Gilbert in which she explains how a joint commitment can constrain collective belief change. So she says, if members of the group speak contrary to the collective belief without preamble, they will be regarded by both themselves and others involved as acting out of line. More specifically, they will have violated obligations they had to the others, and the others have the standing to take other measures responsive to the situation. This would take the form of anything from a mild rebuke to complete ostracism. Even if they do not speak without preamble, but make it clear that they're expressing what they personally believe. Doing this only makes it clear that they are not personally in sympathy with a collective belief that is liable to lay them open to suspicion. Hence, there is a significant initial cost in every case of muting an idea that runs contrary to a collective belief. So Gilbert here is very, she says that a belief, group belief change can be rather difficult if it has to run through this kind of mechanism, because it involves getting all the parties to jointly commit to reject the previous view and to jointly commit to forming a new one. And she actually says elsewhere that for a body of which I am a member, to change its belief requires something akin to agreement to stop believing that P together and to start believing that Q instead, and that this is not easy to achieve. In contrast, like on a summativist view, belief change is more straightforward. When enough members individually change their views, then the group belief change follows. But for Gilbert, this type of sort of difficulty of belief change over time is, for her, a upshot, because she claims that she can successfully account for certain aspects of scientific communities and why scientific communities are resistant to change. She claims that collective belief act as a break to scientific change, and that scientific change is often initiated by neophytes or outsiders. So those are sort of like the two main claims that she says that she can capture using this kind of joint commitment view that she has. I will only be kind of focusing on the first claim, that collective beliefs act as brakes to scientific change, that collective belief sort of constrains what a group can do and what the members can believe, and so changing that collective view takes a lot of effort. And not so much the second claim that she makes, that scientific change is often initiated by neophytes or outsiders, because I think there's been lots of work elsewhere, especially by Brad Ray and Lena Anderson, on doing sort of sociological work and historical work to show that, in fact, lots of scientific change are initiated by scientists in their middle age rather than just young people, and sometimes and often change does not come from the outside; it does come from the inside. So yeah, so that second claim I'm not going to evaluate, so it would be the first claim that I'm going to be focusing on. And it's also that first claim that scientific beliefs act as great brakes to scientific change has been picked up in another paper by Gilbert, Weatherall and Gilbert in 2016, in which they liken collective beliefs in Gilbert's sense to a Kuhnian paradigm, in that they regulate how a group functions, evaluates new evidence, and which projects are deemed as appropriate for its members to pursue. The scientific consensus are collective beliefs formed through a joint commitment by members of the community, and they argue that the joint commitment can explain why normal science in the Kuhnian sense is conservative. And this is a really provocative claim that normal science is it done? Successful normal science is conservative, and that it's resistant to radically changing its core beliefs. So I have more quotes from Margaret Gilbert, especially from that Gilbert and Weatherall paper, but I'm going to try to get through these kind of quickly. So she says, even when there's evidence against a consensus is found by individual scientists, one might expect it to be ignored, suppressed, or explained away by its discoverer, since such evidence would force a psychologically unsustainable conflict between the scientist's commitment to act in a certain way and his or her belief concerning the epistemic warrant for such actions. In the case of evidence contrary to the consensus that is made public, the scientific community also may ignore, suppress, or explain it away. For instance, it may collectively affirm that a crucial experiment cannot have been done properly, or it may assume that facts that are not at odds with the consensus can explain it. However implausible such an assumption really is, for these reasons, scientific communities should be expected to hold certain beliefs in face of considerable conflicting evidence to the point of being, or at least appearing, irrationally dogmatic or epistemically irresponsible. So it's important to note the sort of the psychological mechanism that's proposed by Gilbert, that groups are resistant to belief change because the members of the groups are psychologically constrained by the normative force of the joint commitment. Because the scientific community has reached a consensus that P, so we're a party to a joint commitment to uphold that P, and so when we find evidence against P, you're constrained by your previous joint commitment to uphold P to either explain away that evidence or to ignore that evidence altogether. And she kind of, explains this point further. So this is another quote that, she says, see how a participation in collective belief can have consequences for an individual's private thoughts, inhibiting one from pursuing spontaneous doubts about the group view, inclining one to ignore evidence that suggests the falsity of that view, and so on. So as you can see, so I'm not going to read this whole quote out, but this is a psychological mechanism that she thinks is really at play when one is party to a joint commitment to uphold the group belief, and that when it's a scientific consensus, it prevents the community from making radical changes to the consensus, and that makes the science. So that explains why science is conservative often. Okay, so this, I think this is an interesting observation. So why are groups resistant to changing their views? And I want to just say that, this kind of Gilbertian view on how groups are conservative and resistant to change is not uncommon, right? There are social psychology studies on how groups are slow to change, for example, like corporations that fail to adapt to changing markets. And in the sociology of science literature, there is a prevalent view that scientific change can often be irrational, that it is due to political and social factors rather than epistemic ones. And so on Gilbert's view, how epistemic groups change their beliefs over time comes out not to be a matter of evidence or rationality. The members of the group are not responding to evidence, rather it is due to the normative force of the joint commitment of the will those things, and that commitment of the will is not directly answerable to epistemic norms. We are, I uphold the scientific consensus because I'm party to a joint commitment to uphold the scientific consensus, and not because the evidence tells me that I should uphold the scientific consensus. So are epistemic groups really this resistant to revising their beliefs, even in the face of strong conservating evidence? Just what that Weatherall and Gilbert paper claims. I want to think that this kind of view is bad because it renders epistemic groups non-epistemic, right? That they turns out to be not bound by epistemic norms. So we should consider a different account of group belief revision that does not render group beliefs resistant to new evidence. Because I think there is good evidence, empirically, that there is good evidence that what is really happening in scientific groups is not members of the group being bound by a joint commitment, but rather scientists are genuinely trying to respond to evidence. So I think the emphasis on joint commitment as being sort of the key mechanism for preventing groups from changing their minds is not true. I think the primary reason why groups change their minds is because it's very, very difficult for groups to respond to evidence. So my alternative proposal is that well-functioning epistemic groups are epistemically prudent, but not dogmatic. So they are conservative. However, they're conservative because groups have to settle disagreements among its members over what constitutes evidence for a belief, what are standards for evaluations of that evidence, and to what extent other beliefs must be revised. And in order to settle all of these issues, it takes a very long time, and that process may look irrational or irrational from the outside, but in fact, what is happening within the group is the group trying very hard to decide how to respond to new evidence. So I've been developing over the last few months a view on how groups respond to evidence. Unfortunately, I'm not going to have time to go through sort of all the details of my view today. So instead, what I will do is kind of quickly show you through a case study in the last few minutes. Okay, so do neutrinos have mass? The standard model predicts that there are 3 types of neutrinos and that neutrinos have no mass. And the standard model, of course, is the most well-confirmed theory in physics. It is sort of fundamental to physics to physics today, and all parts of this theory have been extremely well confirmed, except this bit about neutrinos having mass. So and it's really interesting because in the history of this, in the 1960s, there was an experiment done that it's called the Homestake Experiment, that detected about 1/3 of the amount of neutrinos as predicted. And this became known as the solar neutrino problem. So neutrinos are generated during nuclear reactions, and the biggest nuclear reactor that we have access to is the sun. And so the sun is putting out like just billions and billions of neutrinos every second. And so and what physicists have tried to done since the 60s is to capture some of these solar neutrinos. But neutrinos are predicted to be massless and also are electrically neutral. So they're really, really difficult to detect. So you might have heard that they're kind of called ghost particles because they kind of just pass through matter without interacting. And the solar neutrino problem of kind of detecting only 1/3 of the amount of neutrinos predicted was, one of the biggest mysteries in physics for a really long time. And physicists first tried to sort of explain away the results by denying that the experiment was done properly. And then they try to update their the solar model. So like maybe we just modeled the sun wrong. So we were predicting the wrong amounts of neutrinos coming out of the sun. Later, it was proposed in the 80s that This is due to a mechanism called neutrino oscillation, and that explains why there is about a third of neutrinos observed. However, oscillation requires that neutrinos have mass, and that's counter to the standard model. The standard model is really, really well confirmed that would mean we would have to revise the standard model, and it's very difficult to revise the standard model when the standard model is so well confirmed. So more evidence is needed. And so in the picture here, you see in the background it's called the Super Kameo Kande experiment, which is in Japan. It's this you can see just from the sheer scale of it, this is a neutrino detector. They're measuring neutrinos coming from the sun, and building this detector and running it took decades for this thing to come online. And finally, in the late 1990s and in the early 2000s, in conjunction with another sort of similarly complex experiment called SNOW that's set up in Canada, these experiments confirmed the previous experiment that was done in the 60s, and so oscillation was accepted, and with that there was a major break with the standard model. So you can see in this case that what is happening is not so much that physicists are resistant to change, but rather extraordinary changes in our views require extraordinary evidence. And so the physics community was continuously looking for new evidence, and it took a really long time to build these experiments in order to get new evidence. So here's a quote from Bacall and Davis, who were the sort of for some of the key players in the solar neutrino saga from 1976, and you can kind of see the state of physics in this at this point, right? So this was about was just at the when the Homestake Experiment was held, was scrutinized, right? So they say, for the past 15 years, we have tried in collaboration with many colleagues in astronomy, chemistry, and physics to understand and to test the theory of how the sun produces its radiant energy. All of us have surprised by the results. There is a large unexplained disagreement between observation and the supposedly well-established theory. This discrepancy has led to a crisis in the theory of stellar evolution. Many authors have openly questioned some of the basic principles and approximations in this supposedly dry and salt subject. The attitude of many physicists towards the present discrepancy is that the astronomers never really understand astronomical system as well as they think they do, and the failure of the standard theory in this simple case just proves that physicists are correct in being skeptical of astronomers' claims. Many astronomers believe, and on the other hand, that the present conflict between theory and observation is so large and elementary that it must be due to an error in the basic physics, not in our astrophysical understanding of stellar evolution. Another experiment is required to settle the issue whether our astronomy or our physics is at fault. So you can see here that the physicists who are in this community and actively trying to figure out what's going on, they're actively sort of questioning the scientific consensus, right? And they are looking for ways to explain things and exploring all the possibilities in which we can maintain the previous, our well-liked views, to explain new evidence, but also they're very much open to the they're actively calling for to gather new evidence to settle our disputes, right? So, so in that physicists are conservative in defending the standard model because the standard model is so well confirmed. So to disprove a well-confirmed theory requires sort of extraordinary amounts of evidence and evidence that held to a very high standard. And in order to gather that type of evidence, it would require time and energy and having to sort of respond to criticism and solve disagreements, and that just takes a very long time. And I think that explains why science is conservative rather than the fact that people are bound to a joint commitment. So I'll just conclude here that joint commitment is not the predominant process in play in the neutrino case. What constrained the group from revising its core theories is not obligations to each other, but rather the evidence, which is difficult to gather and difficult to interpret. Okay, and I think adopting a view that works, trying to work, exploring how groups can actually respond to evidence and why it's so difficult for groups to respond to evidence, is it gives us a much better handle on these cases of scientific change, rather than proposing that it is just because of a joint commitment, this sort of like psychological mechanism that Gilbert has proposed. Okay, so I will end here. Thank you very much, and I look forward to your questions.